The 75% demand factor for 4 or more of certain types of appliances fastened in place, as referenced in the National Electrical Code, specifically Section 220.53, is applicable to the multi-unit total of those appliances. To clarify this, let's consider the scenario that was brought up. The situation involves a multi-unit dwelling where there are 20 individual units. Within each of these 20 units, there are 2 specific types of appliances that are permanently fastened in place. The question is whether the 75% demand factor can be applied in the scenario, considering that each unit has only 2 such appliances, but the total number of these appliances across all units is 40. According to the code, because the multi-unit total of appliances is 40, exceeding the threshold of 4 or more, the 75% demand factor can indeed be applied. The calculation to arrive at the total number of appliances is straightforward: 20 units multiplied by 2 appliances per unit, which equals 40 appliances. This total is what determines the applicability of the demand factor in this case. To further elaborate on the application of demand factors in electrical load calculations, it's essential to understand the purpose and principles behind them. Demand factors are essentially multipliers that reduce the calculated load based on the understanding that not all electrical devices or appliances will be operating at their maximum rated loads simultaneously. This reduction allows for a more accurate sizing of electrical service equipment, such as service conductors, overcurrent protection devices, and transformers, preventing oversizing and reducing costs. In the specific context of Section 220.53 of the National Electrical Code, the 75% demand factor is applicable to specific types of permanently connected appliances, such as electric ranges, wall-mounted ovens, counter-mounted cooking units, and electric dryers, provided that there are 4 or more of these appliances connected to the same feeder or service. The rationale behind this demand factor is that in a multi-unit dwelling or a large residential installation, it's unlikely that all of these appliances will be operating at their maximum power consumption simultaneously. This is due to the varying usage patterns of residents, different cooking schedules, and the thermostatic controls of the appliances themselves. Now let's delve deeper into how this demand factor is applied in practice. Firstly, identify the specific appliances that qualify for the demand factors per Section 220.53. These typically include electric ranges, wall-mounted ovens, counter-mounted cooking units, and electric dryers. Secondly, determine the total number of these appliances that are connected to the same feeder or service. This is crucial because the demand factor is only applicable if there are 4 or more appliances. Thirdly, calculate the total connected load of these appliances by summing up their individual rated loads in voltamps or watts. This information is usually found on the appliance's nameplate. Fourthly, apply the 75% demand factor to the total connected load. This is done by multiplying the total connected load by 0.75. The resulting value represents the demand load, which is the load used for sizing the feeder or service conductors. It is also important to note that the demand factor is applied after any other applicable adjustments or corrections to the load, such as adjustments for voltage drop or ambient temperature. Consider a scenario where we have a multi-unit dwelling with 10 units. Each unit has an electric range rated at 12 kilowatts. Let's calculate the demand load for the electric ranges. Firstly, the total number of electric ranges is 10, which is greater than 4. So the demand factor is applicable. Secondly, the total connected load of the electric ranges is 10 ranges multiplied by 12 kilowatts per range, which equals 120 kilowatts. Thirdly, we apply the 75% demand factor to the total connected load. This is done by multiplying 120 kilowatts by 0.75, which equals 90 kilowatts. Therefore, the demand load for the electric ranges is 90 kilowatts. This value would be used for sizing the feeder conductors that supply the electric ranges. Now let's consider another scenario where we have a multi-unit dwelling with 20 units. Each unit has an electric dryer rated at 5 kilowatts. Let's calculate the demand load for the electric dryers. Firstly, the total number of electric dryers is 20, which is greater than 4, so the demand factor is applicable. Secondly, the total connected load of the electric dryers is 20 dryers multiplied by 5 kilowatts per dryer, which equals 100 kilowatts. Thirdly, we apply the 75% demand factor to the total connected load. This is done by multiplying 100 kilowatts by 0.75, which equals 75 kilowatts. Therefore, the demand load for the electric dryers is 75 kilowatts. This value would be used for sizing the feeder conductors that supply the electric dryers. In addition to understanding the application of demand factors, it's also important to be aware of the limitations and exceptions to their use. For example, some local jurisdictions may have amendments or variations to the National Electrical Code that affect the applicability of demand factors. Therefore, it's always essential to consult with the local electrical inspector or authority having jurisdiction to ensure compliance with all applicable codes and regulations. Furthermore, there may be specific situations where the demand factor is not applicable, even if the number of appliances exceeds 4. This could be due to the specific characteristics of the installation, such as the presence of energy management systems or other control strategies that affect the load profile of the appliances. In such cases, it may be necessary to perform a detailed load analysis to determine the appropriate demand load. It's also important to consider the impact of other loads on the feeder or service. The demand factor for appliances is just one component of the overall load calculation. Other loads, such as lighting, receptacle outlets, and HVAC equipment, must also be taken into account. These loads may have their own demand factors or diversity factors that need to be applied. The total demand load for the entire installation is the sum of the demand loads for all individual loads. Accurate load calculations are essential for ensuring the safety and reliability of electrical systems. Undersized conductors or overcurrent protection devices can lead to overheating, insulation breakdown, and even fires. Oversized equipment, on the other hand, can result in unnecessary costs and reduced efficiency. In addition to the specific demand factor for appliances, the National Electrical Code also provides demand factors for other types of loads, such as feeders supplying dwelling units, commercial kitchens, and electric vehicle charging equipment. These demand factors are based on statistical data and historical usage patterns and are designed to provide a reasonable estimate of the maximum load that is likely to occur. In summary, the 75% demand factor for 4 or more of certain types of appliances fastened in place is a valuable tool for reducing the calculated load in multi-unit dwellings and large residential installations. However, it's essential to understand the specific requirements and limitations of the code and to apply the demand factor appropriately. Accurate load calculations are crucial for ensuring the safety and reliability of electrical systems. Therefore, it's always recommended to consult with a qualified electrical engineer or electrician to perform load calculations and to ensure compliance with all applicable codes and regulations. Remember to always refer to the latest edition of the National Electrical Code and any applicable local amendments or variations. The code is constantly evolving to reflect new technologies, safety concerns, and industry best practices. Staying up to date with the latest code requirements is essential for ensuring the safety and reliability of electrical systems. Therefore, in the provided scenario with 20 units, each containing 2 fastened-in-place appliances of the specified type, the total number of such appliances would indeed be 40. Because this number exceeds the threshold of 4 or more, the 75% demand factor outlined in Section 220.53 of the NEC can be applied to the calculation of the total load for these appliances. This allows for a more accurate and potentially lower calculated load, which can then be used to determine the appropriate size of conductors and overcurrent protection. Understanding and correctly applying these demand factors is critical for efficient and safe electrical system design. The specific types of appliances that qualify for this demand factor typically include electric ranges, wall-mounted ovens, counter-mounted cooking units, and, in some cases, electric dryers. However, it's crucial to verify the specific appliances listed in the applicable section of the NEC.